So welcome everybody to our very unusual Introduction to Networks class. I am at home. I'm hoping my internet will hold out to allow me to do this. I did not go into work because I'm trying to see if I can run these from home. We're actually allowed to go to our offices if we need to, and I'm actually allowed to go to my data center. So we can't go to work. We just have to let them know we go, because then they come in after we're there and clean. So that's kind of an interesting thing. So I know everyone is in a very interesting time. So let me go ahead up front and let you know that our legislature has stated there will not be an extension to the spring semester. That's what our last word was we heard. We know everything can change, which means we will have summer instructor training classes that begin on May 21st. This class ends in late April, but I'm going to tell you, I will leave this class open as long as I need to up until May 21st. That's probably as long as I can go, because obviously if you're taking the next class, CCNA 2, you're going to need to be finished with this class before you take that class. But just to let you know, I am going to leave this class open if you go past April 24th. Now, it may be quite honestly that you're working at home, it's going to be easier for you to finish it than it would have been otherwise. We've got some flexibility, so hey, look at it this way. I'm recording this, so I probably shouldn't say this, but we're not having to go to any of those stupid meetings we always go to. So there are some advantages to working from home, but the negative is I know a lot of your resources are not available for you. Same with me. It's very hard for me to get to some resources. So we're working on all we can do. We did add a new, there should be 6 pods of V7 pods available. Please be aware that the pods are being shared out across some of my academies. So you may start seeing some contention for getting your preferred time for lab. So if you know you're going to have time tomorrow to do a lab, go ahead and schedule it. But please make sure if you schedule a lab that you use it. We've done some math, and we kind of figured out how much we think we can support on the system across the version 7 and version 6 pods that we have. The other thing, folks, if you are at a school and you're one of our supported academies, and right now, folks, I'm offering it mainly to my supported academies and a couple here and there who I know who are in my instructor training classes. But if you know that you are in a bind and you need a pod or some pods, I'm not dedicating pods to any school. I'm just putting you in the pool. Now, if you got 400 students, I'm probably not going to be able to help you. If you've got 10 students taking cyber ops, I can probably help you. So keep that in mind. I know all of you are in Introduction to Networks, so most of you are not even teaching Cisco yet. But if you have other teammates or teachers at your school and you're really struggling, let me know and we'll see what we can do to help. We're doing everything we can. I also want to show you something else that I put up here recently, and I believe, let's see, hopefully you'll be seeing my screen now. Please, somebody do unmute yourself and let me know you can see my screen. Yes, no, maybe.
I can see it.
Okay, I want to show you this real quickly. I put up some stuff, Stanley Community College, stanley.edu, on here under Future Students IT Academy. Okay, I've got a set of free classes. There, my internet connection's unstable, so hopefully it'll clear up here. If it just lost me, I have a set of free classes here that I've set up. These are the classes inside of NetAcad that can be offered as self-enrolled classes. So Introduction to Packet Tracer, Introduction to Cybersecurity, Cybersecurity Essentials, Linux Essentials, and also did a PCAP, Programming Essentials. All of these, all your student would have to do is click on it, or anybody would just click on it and they can enroll themselves. Now, these classes are not being run by us. In other words, they are being managed, but they're not a actual class that's being taught. It is a class that is for self-enroll. Okay, so once you're in, you've got to move at your own pace. You got to do your own thing. But I wanted to offer that because there are a lot of students, honestly, who are at home right now who have some time on their hands. So if there's a student or students that you have that would be interested in doing any of these, please offer them to them. Now, you also, by the way, at your school can do this exact same thing. If you're interested in seeing how to set up these self-enrolled classes, let me know and I'll schedule a meeting with you on the side and show you how to do it. It's not hard to do at all. Actually, it's very, very easy. But wanted to show you that just in case you have anyone who is interested in doing that. Now, folks, I want to, if you watched our session last week, you noticed that we talked about IP addressing and we talked about what I call classful subnetting, which really, honestly, is what they're talking about here, which is subnetting along boundaries, inside of boundaries. But we also talked more about this, about how looking at a Class C, because all the examples I showed you last week were Class Cs. The way the curriculum teaches it is slightly different than I do. They just try to get you to learn the prefixes and what the variable, or in the video you see here, it's called the magic number. I call it the variable, but magic number, variable, whatever, 6 half dozen. But you'll notice that this is exactly what I talked about. If you borrowed 1 bit, your variable is 128. All right, if you borrow 2 bits, the variable becomes 62, or 64, actually 64. And then on down, you got 32, 16, 8, and 4. Now, the reason you can't go past /30 is because you have to leave 2 host bits. If you don't leave at least 2 host bits, then if we use our formula, remember our formula was 2 to the h minus 2 gives you the number of hosts on a network. Well, if you leave 1 host bit, 2 to the first power is 2 minus 2 is 0. So you have to leave at least 2 host bits. Otherwise, you cannot, you won't have any hosts on your networks. So that is something to consider. Using this method, it is very easy to do basic subnetting. And basically, they're looking at here how to do a /16. So now we're doing it using a Class B network. So we're borrowing 1 bit. I do have a formula, and actually you can use my exact same 7 holy steps. You just change one thing. Notice, if you remember the 7 holy steps that I had, the first step was determine the number of subnets you need. Now that can be either you're given the number of subnets or you determine it by looking at a network, like we said. Step 2 is write out your host bits. Well, you'll notice here, if you've got a network like 172.16.0.0, you're going to have, sorry about that, you're going to have a 16 host bits, because this is a Class B, 172.16.0.0, and so you got 16 host bits to play with. And what they're doing here is they're just showing you what you can do if you borrow each individual number, okay? But you also could do the exact same thing I did. If you need 15 subnets, you'd say, all right, I need to go at least 2 to the what to get 15. So you go down here and look, I need at least borrowing 4 bits. Actually, that wouldn't work, would it? Yep, that would work. You need 15. Now, I will say this. We do not go 2 to the n minus 2 anymore. Our formula is 2 to the power of whatever we raise it to is the number of subnets. If I was in the real world and I had someone say you need 15 subnets, I would probably, if I'm able to do it, in other words, if I'm working with a Class B or a network that's a /16, not necessarily just a Class B, because it could very well be this. I could have been given this. I could have been given 10.102.0.0/16, and that's not a Class B, but it's still starting with the exact same thing. It's a /16 prefix, and that's what we mean by a /16 prefix. There are 16 ones in the subnet mask. So it's 255.255.0.0.0. So when you see a slash prefix and they say /16, all that means is this: 255.255.0.0 or 1234567.8.1234567.8.1234567.8. So in other words, you've got, I think I'm shortening it a 0 there, but you've got 16 ones in the mask. So if it's a /12, /16, /18, whatever, that means the number of ones in the subnet mask. But back to my example. If in the real world I was told I needed 15 subnets and I was able and had a big enough prefix space, I would not subnet it right here in the real world. Anybody know why? Internet connection's unstable again. Hopefully it'll clear back up. The reason why, folks, is because if you did that and you needed 2 more networks, you're out of luck. I'll also tell you another thing. Networks and subnets are like rabbits. If you got 2 of them, you'll end up with 20 before you know what you're doing. So if I had a real world question that said you need 15 subnets, I would try to subnet it up to this space. I would borrow 5 bits instead of 4 bits. Now, on an exam or in packet tracer, for any of our packet tracers that say you need 15 subnets, more than likely it's going to say match as close as possible, then you would have to subnet it to this. Many of you are probably having trouble actually on the packet tracers. You know, the packet tracer subnetting scenarios, you may be having trouble because if you don't pay very close attention to what it asks, then you will subnet it and your subnetting will still be correct. And your subnetting will still work. The crazy thing is you'll put it in the network and you'll have full pingage. In other words, you can ping everything. But you won't be able to get all the points because your subnetting doesn't exactly match what packet tracer wants. Packet tracer is very binary in its grading on the subnetting items. So, well, actually on everything. So be very careful with that. So you notice here again, we can borrow prefixes and we can end up with as many different subnets as we need depending upon how big they are. Like here's a /23. You know, we could take that /23 if we need 100 subnets, we could borrow it, we could borrow a bit and create 128 subnets. Okay, or we could use a /23 to create 128 subnets, which that's basically what we're doing when we borrow down to that level. So here's a /23. You'll notice the variable is 2, and so that will be how we end up getting our different networks, 0, 2, 4, all the way down. Still using the same concepts I was using in my 7 holy steps, because what we do is we find the highest order bit turned on in each octet. That's the only difference in my 7 holy steps when you're passing across bit, what I call octet boundaries. So if we needed to actually borrow into the 4th octet here, we would have a variable in the 3rd octet and we would have a variable in the 4th octet. So let's go on down here and see if we can't find this one. Nope, that's a /18 subnet. They don't have an example and I won't be able to actually easily do it here. Actually, I might be able to. Let me see if I can do it like this. Let's try this. Let's do this 10.102.10. Actually, let's do 00/16. But we're going to borrow all the way down to /25. In other words, we now have a mask of 255.255.128. Excuse me, back off, messed up. 255.128. So we have borrowed from both the 3rd octet and we have borrowed from the 4th octet. So now in my 7 holy steps, in the point where you're finding your variables, you have to say, okay, I have a variable of 1 in the 3rd octet. I have a variable of 128 in the 4th octet. Now, when I go to find my subnet ranges, I would go 10.102.0.0. You always start with that. 2, okay, 10.102. Now, I don't do anything in the 3rd octet yet because just like our numbering system, I've got to roll the 4th octet by all its possible permutations before I can roll the 3rd octet. So it stays the same. And then we go to 127 because our variable in the 4th octet is 128. And then our next will be 10.102.0.128 to 10.102.0.255. Now, if you'll notice, I have rolled the 4th octet by the entire possible range of an octet, 0 to 255. Now what I'm going to do is I'm going to go and look at my variable in the third octet, and I'm going to roll the third octet by that number. So now it becomes 10.102.1.0 to 10.102.1.127, 10.102.1.128 to 10.102.1.255. Now again, I've rolled everything from 0 to 255. So I simply roll the third octet by my variable, which at this time would be this, and so on and so forth until I go through all the possible different ranges, which by the way, oops, sorry, that's wrong. That should be 128. That was just me mistyping, sorry. And that would go all the way down to 10.102. I apologize, folks. I don't know why I mean, I do know why my phone's ringing, but I really can't get to it there. 255.128 to 10.102.255. 255. I muted there so y'all wouldn't have to hear the phone ring, sorry. And that would be way, way down because you'll notice I'll be back in just a second. Sorry, y'all. Okay, I didn't figure you want to hear CVS Pharmacy. By the way, I didn't realize my phone up here would actually play the message at the same time. But the other thing is, if any of you dealt with CVS Pharmacy, it's unbelievable how many times they'll call you about a prescription. But you'll notice this is how it works when you cross what I call an octet boundary, well, what everybody calls an octet boundary, when you cross an octet boundary. And so in our new mask would obviously be 24 bits, 24 ones plus 1 in the fourth octet. Now, this is a little funky because you're crossing the octet boundaries. Are there any questions about this? Let's look at another weird example. Any questions? And they've already got this example in the curriculum, but let's go back and look at it now. They've got this one where you're at /23, and you'll notice that because the fourth octet is not touched at all, it is being rolled every single time. So you've got 172.16.00, and really when you look at this, the ranges here for the /23, let's go back over here. Let's actually do this one here. So let's go 172. Can't type y'all. 172.16.00/23. Okay. So we know it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you notice we've got our variable in the third octet is 2. But we didn't touch the fourth octet. So when we go to looking at our ranges, and this is one thing I wish they would do in the curriculum a little more, is actually show you the full ranges. But 172.16.1.255, and then 172.16.2.0 to 172.16.3.255. And you'll notice the variable is 2 because 0 and 1, that is a that's 2 places or two different numbers. Here's something that's weird. Let me ask you this. And this is a little bit confusing, but I want to ask you a question. If I gave you the IP address 172.16.2.255/23, is that usable? And I want everybody to answer in chat. Is that a usable host address? And why? Everybody answer in chat for me. Is that a usable address? And if so, why? Everybody still there? Hello? Anybody home? Yep. Stephen's saying yes. Yes, Faith. Okay. I got 2 yeses. I should have done a poll. I'm not gonna do that. It's actually kind of cool. I'll start using that now that I know I can do it inside of here. Let's take a look at it. If we take, and first off, we know that the first two, 172.16 is the network portion. So we're gonna ignore that for right now because we know that's the network portion. The 2, which is 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then we've got 1, 2, 3, 4, 5, 6, 7, 8. Now you'll notice if it's a /23, that means we have 9 host bits. Okay, so all of that. But take a look here. Those 9 host bits are neither all ones and they're not all zeros. So that, my friends, is a usable address. Now let's change this to 3.255 and watch what happens. As soon as we change it to 3.255, when we convert it to binary, now all 9 host bits are ones. And so that is a broadcast address for that subnet, and it's not usable. So that's where students can get confused if they don't understand that you have to look at the host bits and make a determination. Are they all ones? Or are they all zeros? And that's one of the rules. I don't think I told you last class, but the host bits cannot be all ones or all zeros. Actually, I think I did tell you that. So they cannot be all ones or all zeros. Questions, folks? Now, I showed an example last week, actually, of VLSM. Now, they've got a bunch of videos here on VLSM, so you can watch those videos. But it's basically about subnetting the networks to fit the number of hosts you have. So we're looking at things differently. With my 7 holy steps, you'll notice that the 7 holy steps are really built around getting you the number of subnets you need. Now, I will tell you this, you can also do it by the number of hosts. You just do it backwards and leave the host bit. So it's not mutually exclusive. But when we're looking at VLSM or variable length subnet masking, you look at the number of hosts on each network and you subnet to fit that. You also can subnet a subnet. So in other words, we've got this 192.168.20.20/24. This could just as easily be 10.10.10.0/24. Wouldn't matter. You're just taking this /24 prefix and you're subnetting it to fit this network. So in other words, you need the host on building A through D, need these number of hosts. So you're going to use a /27, okay, which leaves 5 host bits. And that means 2 to the 5th, which is 32 minus 2, which means 30. So that meets all the requirements for these building A, B, C, and D's networks. The site-to-site WANs are going to go down and do the /30s. Now you'll notice they've done this again, and this is how the curriculum teaches it. And I don't like it. I would not have used the 192.168.20.0/27. I would have made my /30s 192.168.20.0.4.8 and .12 and went above that and pulled out my /27s. So this also is how it's taught, has been taught for years, and I wish they would stop it. They always say get your biggest networks first out of the lowest level, but you go out in the real world and people are going to be like, why am I using .128 for your these links here. Why not .0, .4, .8, 12? So be aware of that. I don't like the way the curriculum does this. I don't think it's the way it's, and I may be wrong. Okay, I'll be honest. I haven't worked in the industry in a while, but all the industry networks I've seen, they use the lowest numbers for their point to points if they can, just because it's simpler. Anybody else agree with me or disagree on that? I mean, feel free to disagree if you've seen it differently out in the real world. And I know you can see it all different kinds of ways and it's still correct, but. Okay, I'll take that as everybody agrees with me. Or at least doesn't disagree enough to make it worthwhile. So folks, here's another thing you can look here at. By the way, if you didn't know, you can actually expand many of these pictures. So we first subnetted it into equal size. So we use our normal standard classful subnet, what I call classful subnetting. And then we just took one of these of 30 hosts and subdivided them into 8 smaller units. That's all VLSM is subnetting a subnet. So again, we did a basic subnetting scheme and then we subnetted it further to get that. Okay, Sabir, what you got? You have a question? Let me see, may have you muted. Hold on a second. Manage participants. No, do I have you muted? All right, go ahead. Ask. Put it in chat, Sabir. So I saw you raise your hand for a question. Or if your mic's working, you're welcome to use your mic. Oh, I can't hear you. Okay. All right. Can anyone else hear me?
I can hear you.
Okay.
I can hear you.
Okay. Okay, Faith, I do apologize for that. I do live out in the boondocks, so I have an 11 megabits per second internet connection, which is not super stable, unfortunately. And the funny thing is, it's starting to rain, and whenever it rains, my internet connection gets spottier. So. No, it's not you, Faith. I think it's me. Yeah, Tamara, or Tamara. Yeah, so it's that's what I had. I got DSL, so when it rains, it gets spotty, and it makes sense because if you walk down and look at the phone lines, they've got like basically a black trash bag around some of the components, which is hilarious. Yeah, I wish. I will say this: if this has showed me anything, it's that our county has got to do more to get high-speed internet to people who live in rural areas. I've actually had to not take a job before because I couldn't work from home, which is ridiculous. You know, it's one of those things to where I'm praying now for SpaceX, and now they're trying to stop it because of the problems with astronomy, which I get that too. Don't get me wrong. I don't want to mess up any of our telescopes. But at the same time, you know, if we can't get some type of faster internet for people who live out in the boondocks, and I don't really live in the boondocks. I literally live 6 minutes from work, 7 minutes from work. So it's not like I'm out in Alaska. But we've got to have faster internet in this country to every single place in the country. And I don't think there's any solution other than maybe SpaceX's Starlink system or forcing companies in your county to, if they're going to do business in the county, they have to offer it to the rural customers. And I don't say give it free, I'll pay for it, but you've got to pull me a line out here that gives me the speed that I need to live in a modern society. So I'll stop now. Watch this. You ready? That was a /rant n/rant. You know, that's my, and I know I did, or rant/rant. So, all right. let's look on down through here. Just looking at how they did it. You know, they basically pulled it out and assigned individual networks to each part of this diagram. And there's an activity. So there's some activities here that you can do it. Now, I'm going to give you some of Kelly Caudle's IPv4 network address planning. The first one is, know for a fact that if you have 10 hosts today, you're going to have 40 hosts tomorrow. Also, anytime you're designing a networking address scheme for somebody, they're going to tell you they have 5 PCs. Then they're going to forget to tell you about the 3 TVs in the office that need IP addresses, the Alexa and the Google Home or Google devices they have in the office, the IPv4 cameras they have that they forgot. Oh, yeah, by the way, the camera's on the network too. So make sure your students understand when they start to design networking address schemes for somebody to ask all of the questions. What are all of the devices on your network? Then I would say plan for 50% growth every 6 months. And that's a lot, I know, but you'll never be called out if you can plan for at least that much, or try to anyway. The other thing, honestly, inside our networks, we're all going to be using RFC 1918 addresses. You're not gonna be using /RFC or RFC 1918. That's the addresses that are for private use inside the networks. 172.16.002, 172.16.31.255, and then 192.168.0.0 192.168.255.255. The other one I'll throw out here just so you know about it, but don't forget a PIPA. If you ever see 169.254.0.0 address on a machine, that means the machine has tried to use automatic private IP addressing to give itself an IP address. Oh, good. Thanks. Good, Spoon. I'll tell you, when Windows 7 first came out, Microsoft really didn't make people aware of what was going to happen when a machine didn't see. It may have even been Windows 95. I think it may have been 95. Well, one of them. But they didn't let people know about a PIPA. And we booted some machines up and they couldn't find DHCP server. And we saw 169.254 and thought somebody had started or had a rogue DHCP server. Did a little bit of research and then found out. But this is also the same address if you got 2 Xbox 360s or Xbox One X's or whatever. If you put them on the same network, they'll boot up and find an IP address in this range, and then you can talk to one another. Okay. All right, folks, are there questions on subnetting? Are there questions on what we've gone over to this point about subnetting? Okay, I'm going to ask again. Let me stop. I'm going to stop the share, and I'm going to stop the recording.